So the first three-dimensional shape we get to talk about in Chapter 12 are prisms. So our objective is to learn about prisms. So in addition to learning about prisms, we're going to also talk about different types of area. Okay, so we'll talk about surface area, lateral area, volume, because now we're talking about three-dimensional shapes. So learn about prisms and their formulas. All right, so what is a prism? A prism is a three-dimensional shape with flat, congruent, parallel bases. Okay, so a three-dimensional shape with flat, congruent, parallel bases. This chapter kind of breaks down into flat top, flat bottom, pointy top, which would be pyramids. So we're going to talk about prisms, and then we'll talk about pyramids too. So let's talk about the pieces individually. So a base of a prism. So what you don't want to talk about is just base. You need to talk about base of prism. Mikey, we're taking notes. So those are going to be the parallel, congruent polygons. And a prism is going to be named by that polygon that is the base. So if the base is a triangle, it's going to be called a triangular prism. If the base is a square, it is going to be called a square prism or cube. If it's going to be a rectangular bottom, it's going to call a rectangular prism. If it's a hexagon for the base, it's a hexagonal prism. Okay, so the name of the base becomes the major part of the name of the prism. Okay, so I'll write in parentheses here. It dictates the name of the prism. Now, we do have an altitude of a prism. Okay, and so what we're going to say is that it's a segment joining the two bases and is perpendicular to both. So we know altitudes are perpendicular, but in this case it needs to be perpendicular to both bases. Now we cannot do any calculations with an altitude because it's an object, so we do calculation with its measurement. So its length is called the height. And it's the height that we're going to use in our calculations. Because it's three-dimensional, we don't just have two bases, we have these sides that separate the bases, and those are called lateral faces. So is everybody ready? May I move the screen? So I need to hold on. All right. So the lateral faces, getting bored with black. Let's put some different colors. So lateral faces are the faces of the prism. that are not bases. Okay. Now, faces is short for surfaces. Okay, so they're just surfaces of this shape. Now, all of them are parallelograms. All the lateral faces are parallelograms. Depending on the kind of prism you have will determine what those parallelograms look like. Okay, so we have two different types of prisms. And the most common one, and the one that we have formulas for, are right prisms. And right prisms have rectangular lateral faces. Okay. And then we also have what are called oblique prisms. And those have non-rectangular lateral faces. So the right prisms, you either can have rectangle faces or you can have square faces, since squares are rectangles. And the oblique prisms are going to have parallelograms. Okay. So again, we name, I'm just going to do a couple of these. We name prisms by the shape of the base. So, for example, what shape is that? Be specific. It's a right triangle. So if I draw a partner exactly the same above him, and I connect the sides up, what I have now is a right triangular prism. So triangular, I added the lar sound that makes it an adjective instead of triangle, which would be just a noun. So the most common one has a rectangular base. And it always looks like it's on a diagonal. Okay. Nope, that's a really lousy one. Let me try that again. I'll do it the way I like to do it. That looks better. So then this would be called a right rectangular prism. Oops, looks like I didn't finish prism over here. Now, the oblique ones just look like the Leaning Tower of Pisa. They're just all kind of slanty. So again, we're going to focus in on the right prisms because those are the ones that we can actually do some calculations with. Are we good? So notice again, every time we talk about something brand new, we have a lot of vocab, and this one's no exception. So in order for us to do any kind of calculations with surface area, volume, so on and so forth, we need to learn some new terms. So a couple new terms. First one is lateral area. And lateral area is abbreviated capital L, capital A, like LA. And it's the sum of the areas of the lateral faces which, because it's area, it's going to be in square units. So these are the quote-unquote sides of your three-dimensional shape. And then if I add to that the area of the two bases, now we're talking about total area. Now it's interesting how this is how our geometry books talks about it, as total area. You're used to hearing it called surface area. And that's what prior information is called it. So I'm not sure where Common Core has gone with its title, but it means the same thing. So when you learned surface area formulas, you're learning the total area of that particular shape. So the total area is the sum of the areas of all the faces. So of all a prism's faces. Okay. So there's a formula that we know for total area. It is not a theorem because it's figured that you can use logic to come up with this. And that's total area is the lateral area of your prism plus the area of the two bases. So the big B is the area of a base. Now that formula is dependent upon what kind of face you have. So if you have a regular hexagon, you're going to use the formula for a regular polygon. If you have a rectangle, it's going to be base times height. If you have a triangle, it's going to be 1/2 base times height. Okay, so the area of the base is dependent upon what shape it is. So that's using the Chapter 11 formulas. So we do have a formula for the surface area, and that's our theorem 12.1. And it says the lateral area of a prism of a right prism equals the perimeter of the base times the height of the prism. So remember what we have here. We've got a rectangle sides. To figure out the area of a rectangle, we have length times width or base times height. The height of the prism is the same as the height of each of those lateral faces. The perimeter accounts for all the sides around. So basically, it's a fast way of figuring out the area of those individual rectangles. Instead of figuring out each of those, you can do it real quickly by using the idea of the perimeter. So the formula looks like lateral area equals perimeter times h. And I'm going to use a capital H for the height of the prism. And the reason why I'm going to do that is because sometimes when you're figuring out total area, you need to know the height of the base. So I'm going to call him little h. Okay, so we're going to distinguish our h's. All right. Now, I did mention a particular rectangular solid where all the dimensions are the same length. So it has a square base and it has square sides. Who can tell me what that's called? A cube. So it's a rectangular solid. And by the way, prism, solid, interchangeable words. With square faces. Okay, just to let you know that one. And then I do have theorem 12.2. Which is the volume of a right prism, so you're going to have no formulas on oblique prisms, equals the area of the base times the height of the prism. So volume is equal to capital B, that's the area of the base, times capital H, that's the height of the prism. So what's great about this generic formula is all you have to know is the formula for the B to plug in. So you don't have to memorize all these separate formulas anymore like you did in the past. You just need to know this generic one and then remember all your formulas from chapter 11. Okay? I think I'm going to stop the notes here. They have some really good examples in the book for you guys to check out. And let me give you some homework.